We're looking at dilations today. So a dilation is a transformation. Okay, so we're still looking at these transformations. It's a transformation that changes the size of a figure. Okay, so you're changing in size. So yes, you can think of it as your pupils. You go to the eye doctor, they dilate your eyes. Okay, so they get bigger. Okay, yeah, that too. So you're changing the size. Quiet down now. Okay, so you're changing the size of a figure. So the figure can either be enlarged or reduced. Okay, so it's not just being enlarged. It's not just getting bigger. You can also reduce something. So you can make it smaller as well, and that's considered a dilation. Shh. We're quiet, please. Shh. So therefore, a dilation is either considered an enlargement or it's considered a reduction. Now, off to the side here, I do want to write out all the transformations that we've gone through. Okay, I want to write down each and every transformation that we have gone through in this chapter. Okay, there are 5. Put your hood down. Okay, what would one transformation be? Do you remember what is one of the transformation we've gone through? A translation. A rotation. Reflection. Now, the other one, okay, that you might not remember, this one was a specific combination of 2 transformations. Okay? Shh. A specific combination of 2 transformations. It was called a glide reflection. Okay, so a glide reflection is when you translate and then reflect. Translate and then reflect. Okay, so that's a specific type of a combination of transformations. The last one is the one we're going over today. So a dilation is still considered a transformation. Okay, so those are your 5 different transformations that we'll be going through this chapter. Now, thinking about what an isometry is, okay? I've said isometry a couple times now throughout this chapter. Thinking about what an isometry is a dilation an isometry? No. Okay, for it to be an isometry, it has to keep that same size and shape. Okay? When you're dilating something, you're changing its size. Okay, so a dilation is not considered an isometry. However, the 4 other transformations are. Okay, so those first 4 transformations are considered isometries. The dilation is not. All right, so moving on here. The new figure may be smaller or larger than the original by a scale factor. Okay, so we do have this scale factor that we're bringing into our figure. The new figure and the original are similar, meaning they have the same shape but not the same size. Now we did go over similar figures in chapter 7. Okay, and we had scale factors in chapter 7. A scale factor is written as a fraction, and it is a ratio of your lengths. Okay, so that's our scale factor that we will use. So dilations are completed with respect to a center point. and a scale factor. Okay, so we have a center point and a scale factor being multiplied in. So if point P at xy is the preimage of a dilation centered at the origin with a scale factor of r, conversation stop, then the image P prime is at rx, ry. So to find your image, all you're doing is multiplying x and y by your scale factor. So you're bringing in that r value, multiplying in that scale factor there. Now to find your scale factor, you need to take your image length from the center point over your pre-image length from the center point. So your image is that prime coordinate. Okay, so you would take the length from the center to that prime value over from the center to your original image. Okay? So we're going to do an example where we're setting up this scale factor. So in example 1, we want to state whether the dilation from B to B prime is an enlargement or a reduction. Then find the scale factor of that dilation. Now on here in our picture, there's a typo, there's no B prime. Okay, B prime is supposed to be this one right here. So you can put in your prime symbol right there next to it. So if I'm looking from my pre-image to my image, your pre-image is this one. And B prime would be your image. Now when I say type of dilation, I mean reduction or enlargement. Okay, so from your pre-image to your image, it's getting smaller, so it is a reduction. Okay, so this one will be a reduction. Now what I want to do is come up with this scale factor. So to find my scale factor, I need my image length, which is B prime, over my pre-image length, which is just B. So I'm going to find the length from my center point, which is going to be this point on the outside here, to B prime. That length right there is 4. Okay, then I need the length again from the center point to the pre-image. So I need this entire length here. That is 10. Okay, so that entire length from the center to the pre-image would be 10, not 6. Okay, you're not finding the length between your pre-image and your image. You're finding the length from the center to the pre-image. Okay, and then I can reduce this fraction to 2 over 5. Now, to make sure that I got my scale factor correct, since I said this was a reduction, it got smaller. That means your scale factor should be less than 1. Is 2 over 5 less than 1? Yes. Okay? It's a good indication that I probably did my scale factor correct then. Okay, so that's a good way to check. Questions on example 1? All right, do example 2. Yes.
Look at the, so it's 5, you and total 15.
We're looking at prime, what one's bigger?
Yeah, it's right there.
Q prime.
Oh, well, it's 5 times.
Q prime over.
And it's fine. So it's total.
From your center to your image. That's 15.
Oh. It's 2 times. And then, oh my God, sorry.
All right, so what type of dilation is this one? It is an enlargement. Okay, so it is getting bigger from Q to Q prime. So for my scale factor, I need the length from my center to Q prime. That's over the length from my center to our pre-image. So this length from center to Q prime is 15. And the length from the center to Q is 5. Okay, and then I would reduce that to 3 to 1. Okay, so my scale factor here is 3 to 1. If I say that the type of dilation is an enlargement, that means your scale factor should be greater than 1. Okay, so your scale factor is greater than 1 when it is an enlargement. Questions on example 2? We good at finding scale factor? The top one? Oh, so you can just look at it. So find your pre-image and then your image. Does this, from this one to this one, does it get larger or smaller? So from here to here, it gets smaller. This one, from here to here, it gets larger. Does that make more sense?
Yeah.
Awesome. All right, so then on the back, to find the coordinates of an image after a dilation centered at the origin, multiply the x and y coordinates of each point on the pre-image by the scale factor of the dilation r. So, just like with rotations, we have this rule to change our coordinates. Okay, remember with rotations, we had certain rules to change our coordinates. For dilation, we just take our original, x, y, and we multiply in our scale factor r to both x and to y. So you're just multiplying those numbers together. So we're going to do an example of that in number 1 here. So what we want to do is graph the image of each polygon with the given vertices after a dilation centered at the origin with the given scale factor. So number 1, we have our given vertices. Our scale factor of r is 0.5, or 1/2. So what I'm going to do first is plot each of these points on my graph. So point E is at -2, -2. Point F is at -2, 4. G is at 2, 4. And H is at 2, -2. Okay, so I get this rectangle here. Now, I do want to figure out what my image coordinates now would be so that I could plot them on my graph, given that scale factor for that dilation. Now, since your scale factor is 0.5, do you think this is going to get bigger or smaller? It's going to get smaller. It's going to get smaller because 0.5 is less than 1. Okay, so your image is going to be smaller than your pre-image and it's going to be closer to the origin. So to find E prime, I'm going to take my x value from E, which is -2, and multiply that by our scale factor, which is 0.5. And I'm going to do the same thing with y. So I'm going to take that y value from E, -2, multiply it by our scale factor of 0.5. Okay, negative 2 times 0.5 is negative 1. And again, negative 2 times 0.5 is negative 1. Okay, I'm going to write it out like that again for f. So again, we need to take our x value from f. That's negative 2. Multiply it by our scale factor, 0.5. Take the y value from f, which is 4. Multiply that by your scale factor of 0.5. Okay, negative 2 times 0.5 is negative 1. And 4 times 0.5 is 2. Okay, we'll do the same thing for g, but I'm not going to write it all out. So for g, look at your x value. Take 2 times 0.5. 2 times 0.5 is 1. And 4 times 0.5 is 2. H, again 2 times 0.5 is 1. And negative 2 times 0.5 is negative 1. So after I find each of those prime coordinates, I can plot those on my graph. So E prime is at negative 1, negative 1. F prime is at negative 1, positive 2. G prime is at 1, 2. And H prime is at 1, negative 1. Okay, so it should get smaller, like we said, because our scale factor was less than 1. It got smaller in my graph, and it got closer to that origin or that center point. Okay, so it should be getting closer to that center point there. Questions on number 1? All right, try number 2. Okay, try number 2 using that scale factor.
Take negative 2 multiplied by 2.
Yep.
Let me just have this hand out.
Yeah.
I get it now. I don't get
So you're just telling me what type of dilation it is. So is it a reduction or an enlargement from your pre-image to your image? So you have to identify which one's the pre-image and which one's the image.
Oh,
So your image is always the prime one.
yeah.
Your pre-image is the non-prime. So from this shape to this shape, did it get bigger or did it get smaller? Bigger. So it would be an enlargement. Okay. Yeah. Okay, then to find your scale factor, you need your prime length from your center to the prime length here.
With don't find that.
You don't need to find x.
Oh.
That's how you find it, but that's you don't need to find it. So you need your prime length from your center point to Q prime.
15.
So that would be 15 over the length from the center to Q prime. Go back to previous one. Okay, well, I'm still teaching, so you gotta wait.
I actually did by myself.
I'm proud of you.
This lesson's easy, that's why.
Good. All right, so here is my pre-image using those coordinates. Now I want to find my image using a scale factor of 2. So I would multiply 2 into each of my coordinates here. So A prime would be at -4, -4. B prime would be at -2, 4. And C prime would be at 4, 2. Okay? So from here I can plot each of those points. Okay, so there would be my image. So your image should get larger because you had a dilation of 2, which is bigger than 1. So your final image there should be larger than your first one, and it should be moving away from the origin. I will. Any questions?